Welcome to the Purdue University Edwardson School of Industrial Engineering's Nano Lab. To my right, I have our recently purchased and installed Bruker Dimension Icon Scanning Probe Microscope. We brought this scanning probe microscope in so that we can conduct atomic force microscopy studies and capability assessments for microchip manufacturing. If you're working to characterize an object on the nano level and you cannot see what the object is, we have to sense the surface. So the way that this operates is and this is a large version of the cantilever that's used in the device. So we have a cantilevered arm with a small probe at the end of the cantilever. Theoretically, at the top of that probe is one atom. So what we do is we flip this over and we bring it into contact with the surface of the part by shining a laser on the back of the cantilever and then receiving that laser in a 4-quadrant photodiode. We can actually determine the cantilever's movement as it traverses the surface of the object by watching how the dot in the 4-quadrant photodiode moves, and then we can create a graphical representation of what the surface actually is, such as you can see on the screen over here, where we can actually characterize topographically the features of the surface, but if we also electrically excite the cantilever, we can take electrical measurements from the surface as well. So not only can we do quality assurance as far as product compliance to the size and shape that meets the customer's demands, but we can also ensure that it is conducting electricity as it should, because all transistors are essentially switches. You can think of them as a light switch. You turn it on or you turn it off. So electrical conductivity is critical to being able to transmit those bits of data, the ones and zeros that allow our devices to work. So this allows us to do that characterization by feeling, sensing, touching the surface, and testing for electrical conductivity. Our students will benefit from this device because this will allow them to become the next generation of quality engineers for microchip manufacturing. As we invest billions of dollars to bring companies into the United States and build factories such as the one that SK Hynix is building just south of campus, this will allow our students a greater advantage to get their foot in the door for those early jobs as they start to fill out these positions as the factories start to expand in their capabilities. By allowing our students to learn these techniques and allowing our students to understand what it takes to measure and characterize items on the nano level, this gives them the skill sets required so that they can go in and become process engineers, quality engineers, and product improvement engineers as they're assessing the capability and quality of the products and the process itself. We're currently using this in our Manufacturing Processes 2 course, so it is an elective course, but in the future we hope to move this into our required undergraduate IE 370 Manufacturing and Processes 1 course, where all of our undergraduate students will have access to this microscope and understand what it takes to measure things on the nano level and understand what it would require to be a quality and process engineer for the microchip manufacturing industry.